In this video, we're going to take a look at the derivative of two inverse trig functions, arctangent of x and arcsine of x. In addition, we will also take a look at the derivative of the natural log of x. Okay, so I'm first going to start off and think about theta equaling the arctangent of x. Okay. Remember, the arctan, or the inverse tan, will find an angle for a given trig ratio. Okay, rewriting that, we could say the tangent of theta is equal to x. And with every trig function and trig ratio, there is an associated right triangle. With this right triangle, I have my angle theta and the tangent given as x over 1. That makes the hypotenuse 1 plus x squared under the square root. Okay, so for example, using that triangle now, I could find the cosine of theta to be 1 over 1 plus x squared under the square root. Okay. So now taking a look at the derivative of arctan of x. What I'm going to start with is taking the derivative of the tangent of theta equals x with respect to x. So since I want it with respect to x, let's rewrite theta as the arctan of x. All right, I'm going to take the derivative of both sides of this equation. So the derivative of tangent is secant squared of arctan of x. Since the inner function is not a simple x, we must multiply by its derivative according to the chain rule. So I'm going to put here the factor of the derivative of arctan of x with respect to x. And on the right-hand side, the derivative of x is 1. All right, notice this factor, the derivative of the arctan of x, is what I'm trying to find. So let's isolate that term, the derivative of arctan of x with respect to x will be equal to 1 divided by the secant squared of arctan of x. All right, I could also write that as the cosine squared of arctan of x. Okay, well, I know arctan of x is just theta. So I'm going to write this as the cosine squared of theta. I would like to know what the cosine squared of theta is. And so cosine of theta, here we wrote the cosine of theta. We're going to use that. 1 over the square root of 1 plus x squared. And we're going to square that. So I've taken the cosine of theta and squared it to get 1 over 1 plus x squared. And there you have it. We have proved the derivative of arctan is 1 over 1 plus x squared. Okay. We're going to prove the derivative of arcsine much the same way. So let's start out and take a look at the fact that theta is equal to the arcsine of x. Rewriting this, we can say the sine of theta is equal to x over 1. We can draw a representative right triangle with the opposite side of theta being x and the hypotenuse being 1. Therefore, the adjacent piece is 1 minus x squared under the square root. And again, similarly, we can say, and find any trig function, in fact, but the cosine of theta is equal to the square root of 1 minus x squared. Okay, so now let's proceed with our proof. We would like to use sine of theta equals x and find the derivative with respect to x. So again, I'm going to write this as the derivative of the sine of arcsin of x equals x. Taking the derivative of both sides, the derivative of sine is cosine. So cosine of arcsin. Since the inner function is not a simple x, I must multiply by its derivative, applying the chain rule. So the derivative of arcsin of x, and the derivative of x is 1. All right, we're going to isolate the derivative of the arcsin of x, because that is what we're trying to solve for. And that will equal 1 over the cosine of the arcsin of x. All right, so remember, the arcsin of x is just an angle. So we're really looking at 1 over the cosine of our angle theta. And the cosine of our angle theta is the square root of 1 minus x squared. So the derivative of arcsin is 1 divided by the square root of 1 minus x squared. Okay, the last proof we're going to look at is the proof of the natural log of x. All right, and I don't actually know if I'd call these proofs or just derivations. Okay, I think by proof we'd have to use the definition of derivative. Okay, and you can prove the natural log of x using the definition of derivative. That's just not what we're going to do here. So we're going to look at the natural log of x, similar strategy to the last one. So if I say that y is equal to the natural log of x, I would like to take the derivative with respect to x. Now, first thing I'm going to do is I'm going to rewrite this. All right, we know that y equals the natural log of x could be rewritten as e to the y is equal to x. Well, and another name for y is the natural log of x, so I'm going to say e to the natural log of x is equal to x. And that is certainly a true statement. Okay, but now I have a function that's written solely in terms of x, and I would like to take its derivative. So we're going to take the derivative of both sides of the equation. Recall the derivative of e to the x with respect to x is just e to the x. The derivative of e to some function with respect to x will be e to the f of x times the derivative of f of x using the chain rule. So we're going to need to use that here since the natural log of x is not a simple x. All right, so taking the derivative of both sides, the derivative of e to the natural log of x is e to the natural log of x times the derivative of the natural log of x. That is in fact what I am trying to find. I do not know that answer yet, but we are going to isolate the derivative of the natural log of x. By dividing by e to the natural log of x. And simplifying that, 1 over e to the natural log of x is the same as 1 over x. And so there you go. The derivative of the natural log of x is 1 over x. All right. Just taking a look at using those derivatives. If I say, what's the derivative of the arctan of 3x with respect to x. Okay, using my derivative of arctan, I know the derivative is 1 over 1 plus x squared. So 1 over 1 plus the quantity, 3x squared in this case. But remember, since the inner function was not a plain old x, I must multiply by the derivative of the inner function. So that would be 3 over 1 plus 9x squared. Okay, what's the derivative of the arcsine of 5x squared plus 2x? Okay, well, the derivative of arcsine is 1 over the square root of 1 minus 5x squared plus 2x quantity squared. Since the inner function was not a simple x, I must multiply by the derivative of the inner function using the chain rule. So that would be 10x plus 2. Okay, one more example. The derivative with respect to x of the natural log of the cosine of 5x squared. Okay, in the previous two examples, we had a composition of two functions, f of g of x, f of g of x. In this last example, we actually have a composition of three functions, f of g of h of x. Okay, so we are going to need to apply the chain rule 2 times rather than just once. Okay, so the derivative of the natural log of x is 1 over x. The derivative of natural log of cosine 5x squared is 1 over cosine 5x squared. Okay, we apply the chain rule by taking the derivative of the inner function. The inner function is the cosine of 5x squared. The derivative of cosine is negative sine. In this case, negative sine 5x squared. But we have another inner function, 5x squared, so we must also multiply by its derivative of 10x. Okay. And there are a few examples of using the derivatives of arctan, arcsine, and the natural log of x.